Welcome everybody to GreenHomeNYC's monthly forum. I'm Liza Chu and I'm excited to have you all join us tonight. We are GreenHomeNYC, a sustainability nonprofit organization that has been around since 2002. Our mission is to promote a more sustainable built environment, and we do this through three main programs for the general public. The first of these is the forums group, which is focused on presenting topics related to every aspect of a more sustainable built environment and lifestyle. We also have the Green Careers group that is focused on promoting green professional development and providing networking opportunities for graduating students or anyone interested in transitioning. And finally, we have the Tours group, which provides opportunities for the general public to have a closer look at many various energy efficient buildings, sustainable businesses, and regenerative practices that we are fortunate enough to have access to in New York City. So if anyone is interested in volunteering, please feel free to reach out to us. You can scan the QR code up on your screen to be taken to our volunteer form. And once you filled out your information, we'll have somebody reaching out to you to see if we can find a fit for you within our organization. So for tonight, we are going to be walking through the groundbreaking conversion of a one-pipe oil-fired steam heating system to individual heat pumps in a 95-year-old 10-unit building in New York City. Our speakers will be Tom Sahagian and Lisa Harrison, who have been very hands-on with the project. Tom was the originator and project manager, and Lisa Harrison is a building resident and board member. And they have been actively involved from beginning to end and know all the intricate details of this project. It was completed in late 2020, and the project is still in its data gathering phase. We're going to be walking through the challenges and lessons learned, the details of installation and operation, instrumentation and data acquisition, almost a year's worth of data, and then the preliminary results, which seem very encouraging, including the costs and savings. We're going to leave plenty of time for Q&A, and you're welcome to type any questions into the chat box. I'll be gathering them for the second half of our forum. We also have subject matter experts in the audience, some of whom are active volunteers at GreenHomeNYC, and they might be answering your questions as well in the chat. If you'd like to ask anything live, we'd ask that you please save that for the end, and you can use the raise hand function, and we can call on you. So without further ado, let's welcome Tom and Lisa.
Thank you, Liza. Thanks to GreenHome for asking us to come and speak. I think I speak for Lisa and myself when I say that we're very, very excited to talk about this project. It's occupied a huge amount of my mind share for the last 3 years, and can't stop thinking about it. But I've got a lot of interesting stuff to share with you tonight, as does Lisa, and I'm going to try to keep it to about a 45-minute presentation so that there will be plenty of time for Q&A at the end, because I think people are going to have a lot of very detailed questions, and I want to answer as many of them as possible. So let me share my screen. Whoops, I didn't want that to be the... Not that lesson, this lesson. Okay, and let me just fix my screen so that I can see the actual slides that I'm, there we go. Okay, so this is the building. It's on the Upper West Side of Manhattan. It's a 5-story, 10-unit building. Walk up, no elevator. You can see that there are party walls or partial party walls on either side, and the front and rear, of course, are exposed. It's a beautiful old building. Lisa, it's what, about 100 years old?
Yes, I believe it's 1926.
Okay, so very, very close. Okay. Wanted to check that there's probably 100 if you add all the major and minor takeaways together, but the ones in no particular order that I think are the most important to talk about are, first of all, that there even before this project started, there was a shortage of properly trained heat pump technicians, and that situation is only going to get worse as more and more people follow the heat pump model, unless the various interested parties work together to develop training programs and then either create incentives or compel contractors to actually use them. We'll talk about that a little bit more later on. Another really critical fact is that someone knowledgeable has to oversee the job who is not the contractor. I've heard from several people, not on this project, but on other projects where it was a fairly knowledgeable consumer, and yet the project ended up leaking out leaking out refrigerant, which has a very heavy global warming potential, refrigerant once or twice in a very short period of time. This is disastrous from the standpoint of global warming. So unless you have somebody aboard who really knows what they're doing, you've got to have somebody oversee the job. Another thing that I will be talking about in some detail a little bit later is that every building is likely to have unexpected weirdness. We had so much crazy stuff. It really was kind of mind-blowing. You just can't make it up, and you can't really foresee it either. But by talking about some of the things that we saw, it might prepare you if you get involved in a similar project. One of the shibboleths in this industry is that, oh, you got to do an electrical system upgrade in order to do the heat pumps. And the fact is that that's not true. In this building, we did not do an electrical upgrade. The heat pumps have been in place for more than a year, and we haven't popped a single breaker ever. So if you can avoid the cost of an electrical upgrade, you've saved a lot of money. So we'll talk about that a little bit later as well. Another kind of, I don't know, litmus test is that some people feel that the existing heating system should just be eliminated, either removed or completely mothballed so that it can't be used again. I think this is a very short-sighted approach, because I think what's going to happen is that once there's a critical mass of heat pumps installed in condensed service territory, their demand peak is going to move from the summertime to the wintertime. And just as they have a program now where they pay buildings to remove demand during, July or August, whenever it's the peak period, they're going to do the same thing to buildings that have heat pumps in them, and I think probably compensate them fairly well for doing so. So I would not get rid of the existing heating system. This is obviously an existing building, and new buildings, they might take a different approach. But so if you're hell bent on getting rid of your existing heating system, I urge you to rethink that. One argument that we had at the beginning was, well, do we consider air sealing as an extra and not include the cost, or do we consider it integral to the job? And I think the consensus became that a certain amount of air sealing is absolutely integral to the job. It's incredibly expensive expensive to reclad a building, for example, in order to reduce the R value, reduce the U value of the walls and so on. But air sealing is relatively inexpensive and gives you a lot of comfort benefits as well as energy benefits. So I feel very strongly that a certain level of significant air sealing is an important part of the job and can't be ignored. One lesson we learned, and Lisa, I know you feel strongly about this, is that if you can possibly drain the condensate from the indoor units inside the building, you should do so. And we'll talk about that a little bit later. Anytime you can reduce the number of holes you cut in the wall, you're definitely ahead of the game. The maintenance contract on this project has been a source of some concern. We'll talk a little bit about that because it affects the overall cost of the project and may not yield the satisfaction that one might expect from such a thing. In this project, we did not change out the domestic hot water. We hope to in the future and install an air to water heat pump for domestic hot water. But right now we're using the existing tankless coil for domestic hot water. And we had a little bit of a surprise with that, which I'll talk about later. And one last thing, that kind of this bland statement, night setback is controversial. What does that mean? Most of you know that in a standard, fossil fuel type of heating system, you have a night setback to save energy. There is this idea afoot in the heat pump community that a night setback is actually detrimental. And I won't go into why people think that. The logic is actually pretty good, but what we've been finding here in this building is that the apartments that don't have any night setback are using the most electricity. A day setback, like if they're away to work, are using much less. So yeah, so we'll talk about that, and I'm sure you're going to have questions about that as we move ahead. All right, so sorry for all the wordiness. So the original system is a cast iron sectional boiler. It's about 40 years old. Despite the fact that it's 40 years old, it's not anywhere near the end of its useful life, which was the source of some controversy in the building. As you can see in the right-hand photo, it's got a tankless coil for the domestic. Yeah, they're missing a little bit of insulation, I know. So pretty standard. And what we replaced it with was an individual multi-split heat pump system, air source heat pump system for each apartment. So each of the 10 apartments has their own heat pump system. And this particular building, each apartment has a Con Ed meter. So they are getting feedback every month through their billing using and to get motivated to reduce their energy use. So I'm a very big believer in having that feedback in there and converting a building to electrical sub-metering if it's master metered. So one of the things that we wanted to do with this project was make it as widely applicable as possible. So even though this building is 10 units, we wanted to set it up so that people living in buildings smaller and larger, much larger, could apply what we've learned and gain valuable lessons from what we did. So one of the first internal controversies we had was, okay, where are we going to put the outdoor units? The kind of the obvious answer would be, or the conventional wisdom answer would be, oh yeah, well, stick them all on the roof. Then they're easy to access for service and blah, 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 blah. Well, there are a number of reasons why I thought that this was not a good idea. One reason was that there was going to be a refrigerant line issue. Top, then going down to the first floor or second floor, you might have too long refrigerant on it. The second reason was that not every building has room on the roof to put all the ODUs. And of course, a very tall building, it wouldn't make sense anyway. So what we ended up doing is we put some of them on the top, on the roof, and you'll see that we kept them a good 24 inches off the roof surface, not only because of snow clearance, but also in case the building needs to replace the roof in the future, they don't have to, lift the outdoor units off the roof somehow and, fiddle around with that. So that was the first area that we put them. Then we put another 4 of the outdoor units on the rear wall in the back of the building, about 8 to 12 feet above the ground. So they're well above the snow line. We did these 2 on the east side of the building and then another 2 on the west side. The building is symmetrical. And then, and these serve the first and second floors. And then I assume everyone can see my cursor. We installed 2 of the outdoor units next to the fire escape. And this was for the buildings, the apartments, in the middle of the building. And we had to be very careful to make sure we weren't encroaching on the fire escape in any way, because we didn't want to, violate any code. So that's where we put 2 of these things. Okay. The indoor units, this particular manufacturer, Daikin, offers a number of different indoor units. They offer these snazzy ones here. What's the name of them? I forget.
Amura.
Amura, yeah, it has a very snazzy name. And they're pretty cool, actually. They also have a more standard looking indoor unit, which some folks opted for. And then still others opted for the floor mount units, which more closely resemble kind of a typical fan coil unit type thing, or even sort of like a radiator or a convector. Some apartments did all wall units, some did all floor mounts, and a few did a mix. So what we found, and Lisa, I would ask you to comment on this. This was a building that used to have, or it still does have, a steam system with radiators, cast iron radiators. And this was a wholesale switch over to basically a forced air type system, which nobody was really used to. What has your experience and the experience of other people in the building been with that changeover?
I think most people, really everyone I've talked to loves the heat pumps. They're incredible. They're quiet. They move the air around. They, heat the room quickly and cool the room quickly. And you have total control, which is a very big factor, because there were always some apartments that were too cold and some were too hot, and people like, different temperatures, of course. And, in every other city in the country, pretty much, people expect to be able to control the temperature in their own living space. But New Yorkers don't expect that and haven't been able to for many years. So that was a very big change and one big incentive for people to want to switch over.
And were people, did anyone complain about, air blowing on them or anything like that?
I think one thing I learned was about location, where to put them, because I have one unit that does, kind of blow. It's like right across from the sofa. Another apartment has told me they have something similar. So, there are various settings that are helpful for that can, make it better. And they in fact, move the louvers so that instead of the air blowing down on you, they blow up, but you still get some. So, if I could do it again, I would not choose that as a location, but it's not a major problem.
Okay, so design issues. This was, we had a million of them. And I'm not going to go in huge detail on it right now. I suspect in the course of answering your questions later on, we'll get to most of these, but these are some of the things that you need to think about if you're going to do a project like this. How much capacity do you need, not only in each apartment, but in each room in each apartment? And so what that means is you've got to do some kind of heating and cooling load calculation. In New York City, anyway, the larger load is the heating load. Different parts of the country are going to be different, but that's what it's like in New York City. How many outdoor units per apartment and where should they be located? I'll talk about that a little bit more detail in a minute. How many indoor units and where should they be located? Even though all of the apartments in this building have the same footprint or a mirror image of the same footprint, two of the apartments, because of the way they were internally divided, had 4 indoor units instead of 3. So you have to be mindful of that, because the way the rooms are laid out will strongly affect how many indoor units you have, what their capacity is, and where they're located. One of the questions that the building residents had before they decided to go ahead with the project was, if we're now not using the boiler for steam anymore, are the pipes going to freeze in the basement? And my colleague, Ian Shapiro, who played a very large role in this project, he was very confident that that was not going to happen. And I tended to agree with him, but I was really hoping that there was a way to measure that. And so we did that. We put like 8 temperature sensors in the basement, and I think it never got below 52, something like that. I forget. So that problem that possible problem has been addressed, I think, in a satisfactory way. A related question was the common area hallways. There's one large steam radiator on the first floor, and that was no longer going to be in use. So were the hallways going to be freezing cold? And the answer to that was also no. I think the lowest temperature indoors in the hallways, because we measured that too, it's like 60 or 62 or something like that. And let's face it, not many people spend very much time in the hallway anyhow, so it turned out to be a non-issue.
Yeah, the hallways, I didn't even notice a difference at all. The basement definitely is colder than it used to be in the winter. So if I'm doing laundry, I'll have to put a sweater on or something like that. It's not a big problem. But, if you are going to spend a lot of time in the basement, you might want to wear a jacket because it is kind of chilly down there in the colder days.
Yeah. How and where should we drain the condensate? We're going to talk about that in more detail a little later. Where do we run the refrigerant line sets? We'll show you some aspects of that. That's kind of a big issue, both logistically and operationally and aesthetically. Do we need to increase the electrical capacity? The answer is not necessarily. And what do we do about domestic hot water? That's kind of a big issue, and we'll talk about that as well. So I got to keep moving this around or I can't see anything. Okay, one thing that was very interesting, originally I had thought that if we used 2 ODUs per apartment and we put one sort of towards the front of the building in these air shafts, and then one in the back, and where we ended up putting a lot of them anyway, that would reduce the line set length and would also just diversify the system a little bit and reduce the amount of demo and stuff that we had to do in the apartments. But Ian pointed out to me that if you look here where it says closed off air shaft, so there's this indent here on this side of the building, and there's an identical indent on the other side, and they are both closed off. Okay, it looks like it's open because you can't see the building next to it, but these are closed off air shafts. So there's no place for the air to circulate. And so if we started putting outdoor units here, here, they would be discharging cooler air in the wintertime. That cooler air would fall down and go into the intake of the next outdoor unit, and so on and so on, and kind of a chain of disaster, and it would harm the efficiency of the system. So reluctantly, I decided that, okay, yeah, I guess we should just do one outdoor unit per apartment. But every building is different. They're going to have different topologies and so forth, and so there's no one size fits all for any of this stuff. I have to tell you, there's no cookie cutters for these projects. So some people, for whatever reason, they are not partial to the look of this stuff called line hide. It's very appropriately named. It does hide the refrigerant lines. Some folks think it makes it look better. Other people, they don't necessarily agree with that.
I think for the outdoors, areas like in the picture here, no one had a problem with that. It was more inside the apartments that there was difference of opinion.
Yeah. Note also that somebody made a goof here and left off a connector, but that's another story. So so some folks, they sort of think it's okay. Other folks, as you can see, this apartment here, they allowed it to be in their apartment, and it actually sort of looks okay. And this is another apartment where they put it in. This is kind of a hidden area, so people aren't staring at it all the time. But it's really a matter of personal taste. The more common solution to the problem was, okay, you've got this exposed line set, which consists of insulated refrigerant pipe and electrical wiring, and sometimes condensate discharge hose. And you can see with these attractive straps that it nonetheless does not really blend into the decor very well. So what a lot of the apartments did is have these soffits installed, and that's worked out pretty successfully. Most people, I think, are okay with it. Of course, it did add to the cost. There will be apartments where the ceiling has been dropped and you can just run the line sets overhead and you don't have to worry about any kind of soffit or anything, but that's something of a rarity. We were able to do it in 3 apartments in this building, but the rest had to have the soffits or the line hide. Okay. Yeah, so this was pretty crazy. I still don't actually believe it. This is a pretty high-tech project, right? We've got these cold climate certified heat pumps. This is a very advanced technology, and you would think that the biggest problem we had with this project related reversing valve, all this other stuff. And you would think, well, that was where the problems were going to surface. Well, actually, no. Pretty much the operation of the system has been fine. There's been a few bumps in the road, but mostly it's been fine. But where we had one really huge problem was finding the right brackets to install the outdoor units on the roof or on the side of the building. Now you say, well, how can that be, right? Well, it turns out that in this particular case anyway, you see this product code here, 87739. It turns out that there are 2 different brackets that have this same product code. And the only way you can tell the difference is one model has the green dot on the box and the other model doesn't. But no one knew this, including the distributor, until we were, I don't know, like a month or so into the project. So that I mean, I'm telling you, you can't predict this stuff. Another area that was somewhat problematic was these condensate pumps. Now, in the wintertime, you're not going to have any condensate inside the apartments. But in the summertime, the indoor units serve a function of cooling the air and also dehumidifying. And so that humidity is going to drop down and it's going to have to go somewhere. You can have it drain out by gravity, or in many cases, you don't have much of a choice and you have to pump it out somehow. So we had originally specified pumps that could fit inside the indoor units so that they didn't look like a giant carbuncle on the indoor unit. But the contractor ordered the wrong pumps, and it turned out, well, it's a complicated mess. But and then we have had some issues with the pumps over time, which Lisa can talk about a little later. But you know, the heat pumps themselves really have been pretty fantastic, but some of the peripherals have not performed as we might have liked. I said earlier that there's this issue with having appropriately trained techs to put this stuff in. And I can't emphasize that enough. There are a lot of details to doing this project correctly. And the knowledge is out there. I know that NYSERDA sponsors a series of webinars by a guy up in Ithaca. He really has it down very solid, and I urge you to check those out if you have an opportunity. But the group that we had here had not been fully trained on the ins and outs of the Daikin equipment. And so that really delayed the installation considerably because we had to have several do-overs. Three examples here. When you're doing the pressure test, the good news is that they included the nitrogen in the test. Some contractors do not. But they used the regulator pressure sensors to establish the pressure, and they're not really made for that. And so they had to basically redo it with the proper equipment, which I'll show you in a minute. Then there's a vacuum test that also has to be done to get rid of a bunch of bad crap that might be inside the pipes. And this particular manufacturer specifies a vacuum of under 500 microns for at least 4 hours. And so what you need to do that is you either have to have a very sensitive analog gauge or you need to have a digital gauge. And instead, this contractor had kind of a halfway in between gauge, which for broad measurements was okay, but in this case, now this is a little bit 100, 250, 500. Okay, so if that's lit there, then you would say, oh, okay, well, it's not above 500, so we're okay. But in fact, what that little bar means is that it's somewhere between 450 and 500. So I'm sorry, check that. It's somewhere between 450 and 550. So we had to get them to go back and get a digital gauge and redo the vacuum test so that we were absolutely certain that we were meeting the manufacturer's requirements. Another potential issue, which did not crop up on this job, but when you're using the vacuum pump to do the vacuum test, you've got to make sure that the vacuum pump is set up properly, that the oil is fresh, and that it's the proper number of CFM. You know, you can't just use any old vacuum pump. So there's a lot of little details about doing the right installation that some contractors either don't know about or choose not to follow. And that's why you need somebody on the job to make sure that they follow it properly. So once we were able to get the proper gauges for the pressure test, this was this was a bit of a challenge, because what happens is if you start off and the pressure is at 550 or a little bit over, which is what the manufacturer recommends, and then they recommend a certain number of hours that it needs to hold that pressure. If the outdoor temperature where you're doing the test changes, then you can have a situation where the pressure drops slightly. So you can see here that it looks like it's about 560, 555, and here it's much closer to 550. Say, oh, the pressure dropped, that means there's a leak. Not necessarily, because if the temperature has dropped even more than that, then actually you're okay. So that's like a subtle thing, but it's something that you have to focus on, because otherwise you could easily make a mistake. This one was crazy. Okay, so in this apartment there is a floor-mounted unit way in the front of the apartment, and so there's this very long condensate hose running condensate from the pump to the back of the building. And almost immediately, when the residents started using their system, which they loved, by the way, they started seeing all this deterioration in their bedroom. And believe it or not, they were unhappy about it. So we had to break this open, and it was a crazy thing. I mean, even when we knew where the hole was, it was really, really hard to see. It was very, very difficult to find. And to this day, we don't know why there was a hole. We think it was probably a sheetrock screw in the course of putting in the soffit. And it just nicked the hose in such a way that this condensate, which was under pressure from the pump, leaked out and wreaked havoc. So that got repaired, and it's all fine now, but that induces an additional cost for somebody, either the contractor or the soffit person or whomever. So it's another thing that you have to be concerned about. And it's another reason why you might choose not to send the condensate outside, because then those kind of problems don't appear. So the refrigerant lines come insulated, but they have to remove some of the insulation sometimes, like when they're sliding it through the wall and that sort of thing. But then what they're supposed to do is they're supposed to put the insulation back on. And as you can see, this happened several times, actually. They didn't do that. Then also, because of having to drill pretty big holes in the wall to put the line set outdoors, you had this situation where you had this exposed brick, you had holes that were passing all the way through, and water, if it rained outside, could leak in and so forth.
Which it did.
Yeah, yes. So these were things that should have been addressed during the initial install, and were not. And so,
yeah, and we did have some very bad leaks because of that. Because when there was a big rainstorm, it just poured into people's apartments. There were 2 apartments that really got it very badly.
Yeah,
that was a big problem.
So we asked the contractor to follow up. We sent them photos of all the issues that we had found, and they brought in a guy who was very experienced in, well, sort of rappelling and so forth. And as you can see, he did do some of the repairs, but they turned out to be ineffective. And he came back another time and it still wasn't right. So Lisa contacted a firm that had done some work for the building. They'd done some parging or whatever and some waterproofing. And they took a real scaffold so that the guy could stand up, and he's not afraid for his life or anything. And you can see that the repairs they did were much more satisfactory. Now, again, if this had been done right the first time, that cost would have been somewhat less, but because it had to come in after the fact and because of mobilization, it ended up costing more than I think it really should have. We also found little things here and there. It's not like a big deal that you see these crushed fins on the outdoor unit heat exchangers, but that you really shouldn't have too much of that. These ones here, I mean, there's a lot of them. They're small, but they add up to something. And then this one here, you can see this one is actually kind of serious looking. And we asked the contractor to get a fin straightener and straighten these out. And they said, well, we don't have one. So I realize, it does cost money to get a fin straightener, but the idea that a HVAC contractor doesn't have one seems odd to me. I mean, I don't know. Call me an idealist, but that was just my thinking. So these things did not get addressed. So now we get to the operations and maintenance part. And I realize I'm going over a little bit, so I'll try to go a little bit faster. So this was actually kind of a big bubble. And we were wondering, well, what the heck is that? So they sent a guy, and the original attachment of the condensate hose was this, which turns out to not be appropriate. And so he changed it to a carburetor clamp, and it worked fine now. It's all good now. The condensate pumps have been a little bit problematic, not a lot, but a couple were making a lot of noise because, what was the reason? There was a clog in the line. I can't remember now.
Well, I'm not sure exactly. And the way we went through a lot. There were several apartments, I think 5 altogether, that have had this problem, that they just started making very loud noise. I had house guests once, and they were woke up. It woke them up in the middle of the night, and they had to come out of that room and drag their mattress out. And other people had similar problems. So we had the installers come back several times. They could not fix it. They didn't know what the problem was. And what happened is, after a while, the noise stopped, mostly, except for one apartment where it just kept going intermittently for, unpredictably, even when the unit was turned off. So the person who came finally and seems to have fixed it, he took out the condensate pump, cleaned the condensate pump filter, and changed the setting. He said he sets it on high, and they were all set on medium. I think that affects how quickly the water goes through. So we think that fixed it, but when he came, it was kind of towards the end of the hot weather. So we'll see next summer if we have any more problems with that.
Just to give you a quick tour of some of the air sealing that we did. On the left, you see a window in the basement that opens into a storage area. It's not really needed for light and air, so we put an indoor insulated panel and air sealed around it so that neither air could get in. And instead of having a, R1 of the window or R1.5 or something, it's now like, I don't know, R6 or R8. So that was a benefit on both the conductive side and the air sealing side. Then on the mirror image side of the building, they have a workout room in the basement. And when we got to the building originally, and I went down to this room and checked it out, where you see this window sash here, I could stick my hand like around and behind that air conditioner. It was basically open to the outdoors, all winter. So what we've done is we put in this removable panel. So it's basically the same as this panel, but it's removable. And so in the summertime, when people are in the gym, the AC can be installed. And then now that it's October, the AC has been removed and this removable panel is in place. So it's not quite as airtight as if it was caulked all the way around, but it's pretty close and it works very well. And it's also insulated. And then, we tried to find all the different areas where there was air coming in and out that we didn't know about, that we needed to control. This was a closet in somebody's apartment, and it wasn't until they moved out that we discovered that this little window was open like 6 or 8 inches. So it's now been closed, and with a little luck, the new resident will will be a little more comfortable, use a little less electricity. We also air sealed the roof door, the front doors, doors in the basement, and most of the apartment doors. And that turned out to be a lot more time consuming and difficult to process. You think, oh, weather stripping, you just slap it on there and it's no big deal. But it's something you have to be really, you have to pay a lot of attention. It's a very detailed process. It's not something that just goes boop, boop, boop. Because what happens is you install the stuff, and then actually when you check it afterwards, it's not like 100% touching, and there's air gaps. You can see light or whatever, and so it's not doing anything. And in this building, we were thrown an additional curveball. All of the all the door frames were metal, and we would drill into the metal to make pilot holes for the screws, only to find that the frames were all full of concrete. And so we had to do this like double drilling thing to have enough space for the screws to get through. I mean, it was a gigantic nightmare. We went through a lot of masonry bits and stuff. So air sealing is important, and it's not particularly expensive, but it's not a piece of cake. You got to really pay attention.
We also had some of the apartments where they had done the air sealing, and then, for example, mine, I couldn't open the door after they did that. So then they had the person doing it had to come back and kind of finesse it and make some changes so that we could open the door. So you have to be able to open and close the doors.
Yeah, no, that's
Be sure to test that.
Yeah. Yeah, just following up on what I said earlier. So it's just more difficult to get this stuff all lined up than you think. And then this is a basement door, and our options were limited. And so we put this stick-on stuff on the other side of the door. And as you can see, fairly soon after we did that, it started to come off. So we had to take a different approach. So yeah, it's not rocket science, but it's much more complicated than you might think. Yeah, and then we felt that we could not compel every resident to do all of the things that we felt were in their best interest. So here's an apartment with a pretty substantial, I mean, this is like about 2 inches from the bottom of the door to the threshold. So there's a lot of airflow through there, but we could not persuade them to get a door sweep or weather strip the door. So, there's going to be those sort of political issues and residential issues that are going to be a part of the project. This is an overall view of the electrical system. You've got the main switch here, the meter pan, and the breakers for the apartments, and also the common area panel. The electric meters are now Con Ed smart meters, which have actually come in very handy in terms of calibrating the data acquisition system that we installed. The main breakers for all of the apartments were 2 legs of 40 amps each. And initially, there was a lot of arguing amongst the technical staff. Well, okay, is that going to be big enough? Are we going to have to upgrade the service and so forth? But after much discussion and back and forth and doing a few calculations, we concluded A, that we did not need to upgrade the service, and B, we were allowed by dint of the fact that the conductors going from the apartment main breakers to the apartments were large enough that we could actually install 50 amp breakers. So that's what we did, because it gave us another 10 amps headroom. So you can see these are
Tom, I'm sorry to
50 amp
interrupt.
breakers. Yes?
Hey, Tom, I'm sorry to interrupt you, but you went out a little bit there, and that sounded like an important point you wanted to make.
Oh, I'm sorry. Okay, well, I'll just quickly say we upgraded the breakers to the apartments because the wire size allowed us to do that. So we went from 40 times 2 to 50 times 2. So we didn't increase the service, but we increased the headroom on the system. And I'm pleased to say we have not popped a breaker in a year, despite very cold and very hot weather. Did that come through, Liza?
Yep, clearly.
Okay.
Thank you.
Yeah, now we'll. Okay, I'm going to go through this quickly. So on the top floor, we found a steam riser with an air vent, emptying into the roof cavity. And another apartment, the cable came in through under the window sash. So that window, it was always open, letting in cold air. And so we were shocked to find out that was all the time. This was completely insane. We found out that on the top floor, the voltage difference between phase B and phase C was 0, and it was supposed to be 208. And we were really scratching our heads on this. It took a while to figure out, but what we finally figured out was that underneath this heavy metal cover in the street, covered up by a car, was the Con Ed wiring that had been improperly connected. So to make a very long story short, they had to get a tow truck, move this car out of the way. They opened up the cover. They had this giant vacuum cleaner suck all the crap out so that the guy could come and fix it. He came and fixed it. I don't know if you can see, he's using a blowtorch to solidify the connection, and now everything is fine. But this is one of those things. I mean, in a million years, I never would have predicted it. I've never seen anything like it, but there it was. This was another crazy one. If you look on the outside, here is the air louver. In fact, it's bigger than it needs to be.
Tom, I'm sorry to interrupt you, but you went out a bit over there as well.
We're getting messages of bad internet connection.
Yeah, I'm sorry about that.
Want to try turning your video off?
I'm sorry?
I'll turn your video off so you can just speak, and we'll see if that helps.
Okay.
Go ahead.
Okay, so this is the air louver for the boiler room, the existing boiler, and it's actually probably oversized. But what we found out when we stuck our head above the ceiling in the boiler room was that a good 2/3 of the louver was dumping cold air into the area above the boiler room ceiling. It was making the floor of the first floor apartment really cold. And so we ended up recommending that they install a new ceiling that was above, the top of the louver, so that we could control that air intake a little bit better, because as it was set up, it was a giant stack effect problem that was going to really make people uncomfortable. Okay, this is the slide you've all been waiting for. Preliminary results. The reason it's preliminary is because we were not able to set up the full data acquisition system until late December of last year. So we have data from late December to the present. So as soon as it gets to be late December of this year, I will have a full heating season's worth of data, and I can true up the numbers that you're about to see. But I want to just mention that when we first encountered this building and we're trying to decide if it was going to be right for the project, it had a lot of things going for it. But one problem was that the BTUs per square foot per heating degree day for the heating system was 10. And I don't know if that means anything to any of you, but what I can tell you is that in my experience, the average in New York City for steam systems is about 15, and there are many buildings that are, 20, 25. You usually only see numbers as low as 10 with hydronic buildings. So I was concerned because, they use the boiler so infrequently that I was afraid we weren't going to see any savings, and it was going to be, the project was going to be a failure and blah, 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 blah. But then I thought, well, you know what? Let the chips fall where they may, because the building had a lot of other advantages. And if we save energy and money here, we can basically save it anywhere. And so what I'm very, very pleased to report is that we did just that. Now there's a lot of numbers here and they're small, and I apologize for that, but I wanted you to see all of the calculations that went into trying to figure out what's happening with this building. So, and this was a very, very difficult calculation to make. Those of you who have ever tried to figure out oil usage for space heating in a multifamily building, you know how difficult it is. What we had in this building is for the winter of 2019, 2020, there were about 4,400 degree days. We calculated them to have used 3,100 gallons. Here's the average price. So there's a subtotal of energy cost here, 7,700 or so. But then we had to also include maintenance costs, right? And for this building, it happened to be it averaged about 2,000 a year for the last 5 years. So it came out to almost $1,000 per apartment per year. We also had the factor of space heat from electric resistance heaters that several of the apartments had used. And it was very challenging to estimate that number, but we think we got pretty close. And it was a total of $900 spread out over all the apartments. Contrast this with the winter of 2020 to 2021. The heating degree days was within 1% or so. Heat pump kilowatt hours, we estimate to be about 21,000, which, by the way, is way less than we originally estimated. The average cost per kilowatt hour, the marginal cost, 28 cents in Con Ed service territory. The annual maintenance contract is $3,000. So you have to include that because you sort of have to have that contract. We can talk more about that later. And then there was one other cost which kind of popped up recently that I hadn't expected. I should have thought about it in advance, but I didn't. Is that when the system was using the boiler to make steam, it was using about 2.5 gallons of oil per day for domestic hot water. But now that it's not using steam, that almost doubled. So over the course of the heating season, and based on the price of oil that we had here, it was an extra almost $1,400 that, in my opinion, has to be included because it's an additional cost precipitated by the fact that they switched to heat pumps. But even with all that in mind, if we look at this middle thing here, we see a cost reduction of 4%. And to my mind, that is absolutely unbelievable. The fact that at this building where we were averaging 10 BTUs per apartment, for 10 BTUs per square foot per heating degree day, to actually come out saving money on energy straight out of the gate, I'm just absolutely flabbergasted by that. And that's without anybody really having any experience using these heat pumps. And we saw a very wide variation. Some apartments were using much more electricity than others. And over time, I think that gap will narrow as I work with them to show them how to reduce their consumption.
Also before air sealing.
Yes, that's right. Right. We did the air sealing afterwards. So yeah, that's also going to have an impact. And as you can see on the energy saving side, 67% energy savings. Now that's a whopping big number. And I want to point out that is site energy savings, SITE. It's not the savings back at the power plant. However, assuming that CLCPA actually happens and the grid is carbon neutral by 2040, the difference between site and source energy disappears, and this will be a real number. So, and in terms of site energy, 67% less. And that's a factor of the fact that the COP of the heat pumps is pretty high. It's the fact that people have individual control of their apartments. And I'm pretty thrilled with that number. Then over here on the right, this is a calculation of greenhouse gas reduction. And what we did is we said, okay, we're using a factor of 0.289 kilograms per kilowatt hour, which was the 2019 greenhouse gas inventory for New York City. And even though we weren't operating under this regime because Indian Point only closed a few months ago, we estimated that the new figure would be 0.319. And even with that, we're looking at a 63% greenhouse gas reduction based on the current mix of electricity generation for New York City. So when you're thinking about 80 by 50, this project basically got us 3/4 of the way, which is not bad. I also note that the oil drop in October in this building was $3.45 a gallon. I got a recent gas bill from someone who has National Grid, and they're paying $2.34 a therm, which if you assume equal boiler efficiency, the gas cost is equal to $3.28 a gallon, which means that with current pricing, you would get similar results if you're a gas-powered building as opposed to an oil-powered building. Now, that may change in the future, but right now, even a gas-fueled building could conceivably get similar results. Okay, I realized that, oh my God, this is taking a lot longer than I expected. I'm so sorry. Okay, we already talked about this. The one thing I want to talk about is if there is any way for you to use the existing pipes for your condensate drainage, I urge you to do it. It was our original plan. I allowed myself to be talked out of it, and I'm sorry I allowed myself to be talked out of it. There are complications with it, which I can discuss if you ask questions about it, but I really like this as opposed to drilling holes in the wall and condensate pumps, which are just gigantic, not gigantic, but they're a pain in the butt. Would you agree?
Yeah, I was really hoping to do that plan, just use the existing risers from the boiler to drain the condensate. It made much more sense than drilling all those holes in the building and having hose sticking out all over the place, dripping, and all the problems we've had. So yeah, it sounds like a much better solution, but we didn't get to do it.
And the last slide is, okay, having said all of this about this project, I think this is the future of heat pumps, and we can certainly talk about that during the Q&A period. And I'm sorry I ran over, but that's our presentation.
That was great. Thank you, Tom and Lisa, for walking us through all of that. I'm just going to jump right in and throw some questions at you. I try to organize everything so that they're somewhat related, so they could all be addressed in a organized way. So some questions on consumer comfort with regards to sound. Anna wants to know, how much noise do the outdoor units make, especially the ones near the units? And Thomas wants to know if the condensate pumps make an irritable whirring noise when they're operating. And Lisa, you had mentioned that after changing settings and filters, the sound was mostly gone for some of these noise issues.
The condensate pumps. Yeah, I mean, when they're operating normally, they're not loud, but there are different kinds of condensate pumps. So the ones we have are pretty quiet. As far as the outdoor units, they are so quiet, you wouldn't believe, because there was some concern at the beginning that they would be noisy, but I mean, they're really not. I have one unit right outside my bedroom window, and I've never even heard it. I mean, we've been out on the fire escape next to them, and you barely hear them, and they're very quiet. At least this type. I don't know if other kinds are different.
Wayne made a comment that the condensate pump issues, he imagines that dust in the air could get into the drain pan, causing some issues like clogs or a faulty sensor that may cause the pump to run when dry and make a loud noise. So a high-speed setting seems like a good idea. Have you tried changing the setting to high, and did that make a difference?
That is what the last person from the company did. From the installers, the last person that came did that. He changed the settings to high, and that did seem to fix it.
That's great.
So,
air quality wise, Anna wanted to know if there are filters in the indoor units, and do the filters need to be changed, cleaned, and how often?
Yeah, there are filters, and they should be cleaned. It's unclear to me how often. I mean, mine don't seem to get that dirty, so maybe every 6 months, but you could do it more often. I'm not sure about that. What do you think?
I think, do it every 6 months at first, and then if they're pretty clean, then spread it out further. The one time that you did it, when I was taking pictures, it was pretty straightforward process. It didn't take very long. There wasn't a huge amount of dust on it, but it's going to vary from apartment to apartment, of course.
Yeah.
But it's got to be done. You got to do it. I mean, there's no question you got to do it.
Right. Piyush, hope I'm not butchering your name, mentioned not directly related to HP. Did you consider adding ceiling fans to move air around more efficiently within the apartments? Or how's the airflow with what your setup is right now?
I would not add a ceiling fan for that reason. I mean, you might want to add one as a substitute for the, in other words, if you want to keep the heat pump off and just use the fan for convective cooling on mild days or whatever, I think that's probably a pretty good idea. But in terms of the airflow, first of all, they're a lot noisier.
What are
So
ceiling fans?
yeah. No, these things are incredibly quiet, and they also have a feature where not only can they be made to go from side to side, so that they're not like blowing constantly in one location, but they also, this particular one, the snazzy one, has a occupancy sensor, and if you're sitting to one side of it, it will actually automatically point the air in the other direction, so that it's not like blowing right on you. But as far as I know, there really have not been any significant complaints about air movement or whatever. Yeah.
No, they seem to, they move the air around pretty well. I haven't heard any complaints at all.
Daniel wants to know if, in general, do the apartment occupants feel that they are more comfortable now? Is the individual control after air sealing a measurable effect based on customer occupant comments?
Definitely. Yeah, I mean, just having the control and being able to set it to how you want it. If you want to have more heat, have more heat. If you want less, I mean, people are much more comfortable than with the boiler, which you had no control over, and came on and went off whenever one person decided it should do it.
Questions regarding design and install. Anna wants to know why you didn't put a heat pump in the basement workout room.
Very simple reason, because it costs too much. The basement room, first of all, it's not used a lot, the workout room. Also, when it is used, you get kind of sweaty and whatnot. And they had been operating it with the air conditioner in the window and the window kind of open for years. So this only improved the situation.
Rebecca wanted to know if you had considered a VRF design, VRF system when you were designing.
Yeah, we considered it and rejected it immediately.
Do you want to explain that?
There were send me their email and I'll give them a detailed discussion. I don't want to, there's a lot of other questions. VRF has its place, but I prefer a system where each resident is accountable for their own energy consumption, and with VRF, it's not easy to do that, and there's other issues, and so I'm not really in favor of it. And in fact, there's a lot of evidence to suggest that they're less efficient. So, but if you send me their email, I'll engage them directly. Sure.
With regards to refrigerant, Wayne wanted to know why. You wanted to know if you had any concerns of exceeding refrigerant concentration limits for the spaces that you ran refrigerant line sets through. I believe you were really close with some of these calculations, if I remembered correctly.
I'm not sure what the question is asking. What I can tell you is that for any of these systems, there is a maximum refrigerant line length that is acceptable, and each manufacturer has a slightly different number. And of course, it varies for different kinds of refrigerants and so on. we actually came pretty close in a couple of the apartments to exceeding that limit. And so that was a possible issue. It was resolved and it hasn't been a problem. But yeah, I mean, the apartments in this building are long and thin. You know, they're about 80, 85 feet long. And so especially if you have an outdoor unit all the way in the back, you know, you're looking at some pretty lengthy refrigerant line runs. So, which is why I originally wanted to have 2 outdoor units, right? One in the back and one towards the front, but we weren't able to do that.
George wants to know, since, as you mentioned, the boiler was not at the end of its useful life, why did you decide to make the transition? And what were the benefits that the board considered to make the decision considering the cost?
Well, there was some controversy about whether the boiler was at the end of its life. So there were a few shareholders who really were worried about it just because of the age of the boiler, and were, you know, very pushing for replacing it. So that was, you know, one factor that some people were worried about it, even though it turns out that it is still operating fine. I've had several engineers look at it, and they've all said it, you know, you don't need to rush to replace it. But, you know, we had an engineer some years ago who, you know, did a whole evaluation of the building and said, oh, this is this old boiler, you should replace it next year. You know, so that was kind of what some of the people were going on. I personally wanted to replace, well, another reason was because of control. I mean, people really wanted control over the heating and cooling. And when they learned more about heat pumps, that, you know, more and more people were interested in that. I also wanted it because of the environmental issues. So there are a number of reasons.
Regarding air sealing, quite a few questions. Daniel asks, wasn't the sealing of every hole created part of the original contract spec for whoever had the contract to make the installation? In this case, was air sealing included in the contract installation?
Well, not directly. I mean, air sealing where they made a penetration in the wall, yeah, that was part of their scope. But the weather stripping and so forth, that was something that there's this fantastic guy who basically can build or fix anything, who has done a lot of work in the building, and he and I worked very closely together to put together the air sealing scope, and he did it, you know, bit by bit. So he was paid separately to do that.
Carrie Jackson asks, in terms of air sealing common areas, they're in the Art Deco building with glass and ornate metal grate front doors. So they're struggling to imagine how to air seal that or some decorative frosted glass windows. Any thoughts for aesthetic details like that?
If you can give me their email, I'll address that.
That would work. Aussie wanted to know what material was used for air sealing the roof doors.
Well, the same material pretty much was used for almost all the doors. There's a company in the Bronx that used to be called Zero. I know it's kind of an odd name, but they're now known as Legacy, and they make some pretty high-end weather stripping. So, they make a huge range of different products, and it actually took a while to figure out which was the right one. But for the vertical and top horizontal of each door, we basically use the same stuff, with the exception of some of the downstairs outdoor doors. And then depending on the gap and the threshold underneath each given door, we would either use an automatic door bottom, or we would use a more standard door sweep. So it varied from door to door, but the roof door, we used an automatic door sweep. Automatic door bottom, I guess they actually call it ADB.
Specific to energy questions, Asi wants to know what your building rate was after the conversion.
What?
The building grade.
Oh, this building is only 10 units, so it's not covered by that law. So, but I mean, 10 BTUs per square foot per heating degree day. That's pretty good.
Thomas asks, how did you determine how much kilowatt hours was used for heating versus other uses for each apartment?
Well, that's a very interesting question. We developed a data acquisition system that obtained the kWh for each heat pump. So we didn't have to futz around with trying to separate the heat pump kWh from the apartment kWh. So that information is actual kWh for each heat pump only. And if they want specifics on it, have them email me. My email is at the end of the slideshow. Oh, I forgot to show that. Give me their email and boy, I'm going to be busy, but that's okay.
Put it in the chat.
Yeah, you could put my email in the chat. If anybody wants to ask a question afterwards, tomorrow, the next day, just email me and ask your question and I'll do my best to answer it.
I will share his email in the chat, everyone. I'm running back to the chat box right now. Byron's asking, how have you thought about planning for rare events like power outages, flooding, etc.?
Well, the short answer is that if there's a power outage and you have a standard heating system, it's not going to operate anyway because you need electricity for the burner. If you had a generator, I guess you might be able to do that. A longer answer is that if you reclad parts of the building, the resilience of the building will increase dramatically because even if the power is out for a few days, the indoor temperature doesn't drop very much. I don't want to give a glib answer, but smaller building like this, there's almost no way that they can afford a generator. And in fact, generators are really expensive and they sit around and do nothing 99% of the time. So it's my current feeling is that it's not worth it unless you can really get it done for not very much money.
Wayne asks that you please expand on potential obstacles and solutions around using existing piping for condensate. What conclusions did you come to regarding the corrosive effects on typical steam piping?
So the big objection was that the manufacturer of the heat pumps was concerned that if we drained into the steam system and then some rogue resident went down and turned the steam system on, in wintertime, and without telling anybody, and so all the valves on the condensate drains were open, that it would destroy the indoor units and I don't know whatever. And I felt that was. It was possible. It's possible, like, I don't know, like an asteroid hitting the Earth. So, but that view prevailed. As far as hurting the inside of the pipes, you can understand that these are pipes that are 100 years old and have had water in the form of steam and then condensate going in and out of it, for 100 years. The condensate is sometimes slightly acidic because of carbolic acid, whereas this condensate is generally going to be practically like distilled water. So I don't see that being an issue.
Here's a fun question for you, Tom. What about heat pump domestic hot water?
Well, yeah, what about it? I mean, I'm all in favor of it. The problem is that right now, the only heat pump water heaters that you can get are either these kind of odd hybrid units that are good for maybe your house if the circumstances are favorable, or these giant units, you know, for commercial grade, and there's not a whole lot in between. We are hoping to get a model that is, we think, going to be introduced into the New York market sometime next year. And if we do, you know, we'll do a full research project on that to see how it all worked out. But yeah, I'm all over it, man.
Andy would like to know in all caps, return on investment and payback.
Well, I mean, that question is really, I mean, the question is whose investment and whose payback, right? Why are we doing this? We're doing this because we want to reduce the amount of greenhouse gases going into the atmosphere so that the ocean level doesn't rise and put half the globe, you know, that's currently above water, underwater. Okay, so what that means is that individual buildings have to think collectively and act collectively, because if they only act in their own narrow economic interests, then obviously nobody's going to do it, because the payback is many, many years. But if you think about it collectively, if everybody does this or something similar, and the ocean levels don't rise, then that's trillions and trillions of dollars saved that, you know, is ultimately going to be paid by us, right? Because it's going to be tax money or whatever that's used to, you know, whatever, rebuild these buildings or whatever, resettle people. I don't know. Not to mention all the places on Earth that'll be unlivable because it's too hot and so forth and so on. So to my mind, the whole ROI and payback question is pretty much irrelevant.
I've shared Tom's email in the chat. It's 7:59 right now. I just want to wrap up the recording for this meeting, but everyone's welcome to stay to continue to ask questions. I'm just going to share screen right now really quickly if I can navigate. So thank you everyone for coming to the closing forum of the year. GreenHomeNYC is always open to new topics, and we like to explore many sustainability topics. If you've enjoyed your evening, we'd like to invite you to GreenHomeNYC's upcoming events, and the next ones will be in January. We always start off the year traditionally with the Green Catwalk, which is a selection of different topics at the forefront of sustainability. We also have our Green Careers event on the second Tuesdays, topic to be determined. And if you're interested in volunteering, it's always right before our general forums. As well, if you have any thoughts on tours to offer our audience, please reach out to us. You can follow us on all of these social media channels. Reach out and don't be a stranger. Oh, I didn't share my screen. There you go. Here's all the upcoming events. And our tag is GreenHomeNYC for all social media platforms.